Hi everyone, we're going to do an example where we'll need to solve the right triangle. Here it is. Solve the right triangle ABC if side A is 10 feet and side C is 13 feet. We always start by making a labeled sketch. Here's the right triangle. I'm going to add to this picture what I'm given. So side A is 10 feet. And side C is 13. To solve the right triangle means to find all its sides and its angles. So we'll need to find side B, angle A, and angle B. Angle C we already know it's 90 degrees. It doesn't matter in which order we're going to find the unknown sides and angles. A lot of times there are several options, but if I decide to go in order, then first I'll have to find side B. What do I use to find side B if I know side A and C? Well, here I know two sides of the right triangle. I need to find the third side. We can use the Pythagorean Theorem, right? So by the Pythagorean Theorem, a squared plus b squared, where a and b are the legs of the right triangle, equal to c squared, where c is the hypotenuse. So from this equation we know side A, 10, so that's going to be 10 squared, plus b we don't know, so I'll just leave it like that, b squared equals, and then c is 13, so 13 squared. That is 100 plus b squared equals 169. I subtract 100 on the left and on the right. So b squared equals 69. And to find b itself, we'll have to take square root on each side. Since b represents the length of a side of the triangle, it's going to take a positive value. But since 69 is not a perfect square, let's use calculator to approximate the value of b. Square root of 69 equals, and on this calculator to change from the exact answer to the decimal approximation, I need to press on this button here, and that's what we get. So if we round to the nearest tenth, one decimal place, then the answer is going to be 8.3. So side B is approximately 8.3 feet. I'll add answer to my list and I'll place it on the sketch. Well, let's move on. Let's now work on angle A. How do we find angle A? Now in this triangle we know only one angle, right? Angle C, which is right angle, or 90-degree angle. And that is not enough for us to compute angle A. So we have to use sides. And that means that we're going to use triangle trigonometry to find angle A. In other words, we'll have to pick one of the trigonometric functions, sine, cosine, and tangent, and use it. Now which one we should use? We know all three sides, but two of them were given, and we know their exact length. And one side we found ourselves in step 1, and remember that is approximation, that is not the exact answer. So we said it's approximately 8.3, we had to round. And since we know that to maintain accuracy, we always try to use given information as much as possible, we will go with side A and side C. What are the sides with respect to angle A? Well, side A is the opposite side and side C is the hypotenuse. So what trigonometric function involves opposite side and hypotenuse? It's the sine function, right? So we know that sine of angle A is the opposite side over the hypotenuse. In other words, sine of angle A equals opposite side is side A, which is 10 feet, and then hypotenuse is 13. 10 over 13. So with what we just put together, we know what sine of angle A equals to. But what is angle A itself? We know function value of 10 over 13, but we don't know angle itself. When that happens, we'll need to use the inverse function, because remember, the inverse function is the one that produces angle measure. So to find measure of angle A, we'll have to use sine inverse function, where we input 10 over 13. And of course, that's something that we'll have to compute using calculator. In a lot of calculators, inverse functions are written right above trigonometric functions. So if I have sine button here, right above I have sine inverse. So it means that to activate it, I have to press shift and then sine. Here I have sine inverse. And then I'll place 10 over 13, so it's same as 10 divided by 13. I purposely choose not to approximate 10 over 13 so that I have the most accurate answer possible. So this is how I'm going to input in the calculator. I press enter and calculator gives me the answer. I always double check that I'm using right units. D above tells me that I'm using degrees, so calculator tells me that angle A is approximately this value. If I want to round it to the nearest tenth or one decimal place, it's going to be 50 point. The first digit after the decimal point is 2, but since 8 follows it, I have to round up, so it's going to be 50.3. So that's approximately 50.3 degrees. Okay, so I recorded my answer here and I placed it on the sketch. And finally, we have to find the last angle, angle B. At this point, we already have 2 out of 3 angles in this right triangle. Since one of them is 90, it means that the sum of angle A and B is also 90, right? All 3 of them together is 180. So angles A and B are complementary angles. The fastest way to find angle B is going to be simply taking 90 and subtracting 50.3. Let's do that in step 3. So to find angle B, we take 90 degrees and subtract 50.3 degrees. That is approximately 39.7. And the reason I'm saying approximately is because 50.3, the measure of angle A, is also an approximate value. So I added that answer to the list and to the sketch. And with that, we can see that the right triangle is solved. We know all sides and all angles of this right triangle. At the end, I'd like to show you or remind you how to convert degrees to degrees and minutes, just in case if the problem you're doing requires that. So let's try that for angle A. So we found that angle A is approximately 50.3 degrees. Well, that is same as 50 degrees plus 0.3 degrees. So what we do next, we write 3/10 of a degree as 0.3 times 60 minutes. Well, because in 1 degree it's 60 minutes. Let's calculate that part. 0.3 times 60 is 18. So that means that the alternative answer is 50 degrees and 18 minutes. Let's try it for angle B. Angle B is approximately 39.7 degrees, so it's 39 degrees plus 0.7 times 60 minutes. 1 degree is 60 minutes. That is 39 degrees, and then 0.7 times 60 gives me 42 minutes. So these are the measures of angles B and A in degrees and minutes.